So as already announced by Mr. Chairman, I will present the LIQUEFACT project, a large European project where a lot of research groups are involved, and so I used some slides or figures from all the groups, so I stated all the contributing colleagues. As a civil engineers, maybe we should look to the Eurocode for the definition of the term liquefaction. And the Eurocode says that liquefaction shall be referred to as a substantial decrease in the shear strength of the soil caused by the increase of pore pressures in saturated cohesionless materials during the propagation of shear waves. Basically, or in most cases, this is an earthquake, such to give rise to significant permanent deformations, which we'll see on the figures later, or even to a condition of near zero effective stress in the soil, meaning that soil literally becomes a liquid for maybe just for a fraction of time. Maybe this is one of the most known photos of liquefaction phenomena from Niigata earthquake in Japan in 1964, but we have more cases from recent earthquakes. For instance, maybe the most known and most investigated in Christchurch in New Zealand in 2011, then in Turkey, and there are other liquefaction manifestations during recent earthquakes, for instance in Hokkaido in Japan, in Fukushima, Japan, in Emilia-Romagna in Italy in 2012, and maybe you have observed the dramatic liquefaction phenomena in Palu, Indonesia during Sulawesi earthquake last October or end of September maybe, where literally a flow of liquefied soil demolished a large area in Palu. It is a devastating event. Just for as a case, in a small town with over 10,000 inhabitants in Emilia-Romagna, the reconstruction costs reached nearly to 300 million euro in total, or over 120 million just for the reconstruction of private houses. So the costs of such event or the damage is huge, and what the damage looks like. So it's basically tilting, overturning of buildings, it's settling of buildings, and it's heave of the ground adjacent to buildings. And here you have always a man standing in front of the houses, so you can see how large settlements can occur during earthquake. So more than enough motivation for LIQUEFACT project, which goal is to develop a comprehensive understanding of liquefaction disasters and applications of mitigation techniques, those already available, and some new are being developed, and as I will show you, to increase the community resilience to earthquake-induced liquefaction disasters. So the project started in 2016 and will be completed in October this year. It involves 11 partners from Norway, UK, Portugal, Italy, Slovenia, and Turkey. And it is organized in 9 work packages. I'm going to briefly present you the 6 technical work packages. Here are listed all the partners with lead researchers. So if you will look maybe for the publications coming from this research, you can use this list. So the sequence of work packages is such that first one deals with hazard, then with the vulnerability of structures, and so on. So let's go through. The first technical work package deals with European liquefaction hazard map, so the macrozonation process on a European scale, and methodology for localized assessment of liquefaction potential on a local scale. in the framework of this work package, the ground characterization on 4 different sites in Europe were performed. So in Emilia-Romagna region in Italy, in Lisbon area in Portugal, in Brežice area in Slovenia, and Marmara region in Turkey. One of the tasks was also to produce a catalog of historical liquefaction occurrences in Europe, and then a European liquefaction hazard map is being produced. A validation of this European liquefaction hazard map will be done for the 4 investigated sites within the project. So this is a map of historical liquefaction occurrences in Europe. Probably it's not surprising what these dots are, but maybe it's interesting to observe that liquefaction can occur at the magnitudes as low as 4.5, and we have many evidences at earthquakes of magnitude around 5 to 5.5. One of the outcomes is also the liquefaction susceptibility map. So this map does not involve the earthquake hazard, it's just the susceptibility of the ground. And here, if we combine the seismic hazard with the liquefaction susceptibility map, we get something like this. This is not the final version. The methodology is still being worked on and improved, so the final version will probably look a little bit different, but nevertheless, the higher liquefaction probability is shown in the places where the evidences of previous liquefaction manifestations were found. Then the microzonation is done for the 4 sites in such a manner. So the maps will be produced in terms of liquefaction potential index or liquefaction severity number as indicators for the liquefaction. Our contribution, Slovenian contribution to the work package 2 was the site characterization at 2 locations in Brežice and Bohinj, where we designed something in the in the ground potentially susceptible to liquefaction, or we had in the Bohinj case an hypothesis that in the recent earthquake, the crack that you can see along the lake shore was produced by liquefaction, which turned out to be very unlikely. And then we have done the macrozonation, or we are doing the macrozonation study for the Brežice site. The next work package is dealing with the structural liquefaction resilience and vulnerability assessment methodologies. So the main objectives and tasks are to develop efficient numerical procedures for the simulation of liquefaction-induced damage in critical structures and infrastructures. The assessment of the vulnerability of structures and lifelines on liquefiable ground, and development of numerical model able to represent the complex behavior of interacting structure soil system with liquefaction susceptibility. So basically, the vulnerability of structure was being studied, and mainly the 4 types of them. So 2 structures, reinforced concrete and reinforced masonry, and linear lifelines, so embankments, traffic line, and pipelines. The reinforced concrete structures and embankments were dealt with theoretically or numerically, while the masonry structures and pipelines were, so their vulnerability to liquefaction was assessed by empirical evidence coming from Emilia-Romagna region for the masonry structures, and from the Christchurch for pipelines. I'm afraid I'll have to skip this one. So one of the main, or the most, the task that required the most time to the researchers of University of Porto who led this task was to come up with the macro mechanism approach to study the building behavior or vulnerability of buildings on the liquefiable ground. So they distributed the task on to the sub-models or macro models in order to come at the end to the fragility of structures on liquefiable ground. Again, our contribution to the work package 3 was to assess the vulnerability of traffic embankments on the liquefiable ground, and structural colleagues designed a simplified method for rapid risk identification of soil liquefaction and structural damage using response history analysis and simplified nonlinear model. It is a relatively simple model, but with nonlinear ground response and nonlinear building, and the aim is to make a rapid assessment, so to have an answer to the question, do we have to study this structure in more detail or not? The work package 4 deals with the mitigation measures, and I like this work package most, although we don't participate directly. The colleagues from University of Napoli, Federico II, exactly where our keynote speaker comes from, they studied the treated soil in the laboratory on the samples, in small-scale centrifuge tests, and on a full-scale trials on a selected test site in the Emilia-Romagna region. And then, of course, some numerical works to combine all the results in a single conclusions are made. The studied liquefaction mitigation techniques were horizontal drains and induced partial saturation as a new developments, and vertical drains as an existing popular measure to counteract the liquefaction risk. Why these new methods? Because we have a lot of existing structures, and it's extremely difficult to do any conventional mitigation techniques under the existing buildings, but the horizontal drains can be installed without affecting the building, and also induced partial saturation. What does it mean? It means insufflating the air bubbles into the ground in order to make the pore water more deformable, so less stiff, and hence to reduce the highest possible pore pressures being developed during the earthquake event. So in the centrifuge tests, the colleagues exactly proved or investigated the influence of vertical drains, horizontal drains, and induced partial saturation. And you can see on this graph there that all the measures are effective. Of course, all of them have their weakness and strengths. And then in the field trial, again, virgin soil was tested. And you can see the relative pore pressure being equal to 1 means liquefaction, and then considerably lower numbers with drains, with horizontal drains, and with induced partial saturation. How was this done? Using a mega shaker, so it's machine equipment capable of inducing vibrations in the ground in order to provoke liquefaction or increasing of pore pressures. Then the next work package is dealing with the economical part and the consequences of earthquake-induced liquefaction event, and then the costs and benefits of installing some mitigation measures. The work package 6 will produce liquefaction mitigation planning software, and this will integrate all the developed methods in one single toolbox, which will be available to the researcher dealing with the liquefaction. And this software will be able to assess hazard and risk, and will assist to plan mitigation measures, and in terms of risk, physical, economic, and social impacts will be considered. Work package 7 will validate everything based on the case studies, where a lot of evidence have been collected. So in Christchurch, Terre del Reno, Urayasu in Japan, and Adapazar in Turkey. So to conclude, I believe that LIQUEFACT has already provided a large amount of research outcomes, so everybody interested in this phenomenon are welcome to read the publications coming from the research group, to download the software when it will be available at the end of the project, to visit the web page, and maybe you're interested to participate in the workshop, the final workshop, which will be held in Pavia in October this year. Thank you very much.